So let's look at our last example for the week. Let's let f from R to R be defined by f of x is x cubed plus 1 over 2. And the first thing I want us to do is prove that f is bijective. And after that, because f is bijective, its inverse is a function. And so what I want us to do then is determine f inverse of x. So let's start with part A, prove it's bijective. Remember there's two parts, so we must show f is 1 to 1 and onto. So let's start with the 1 to 1 part. Let's assume f of A equals f of B, where A and B are in our domain, they're in R. So then plugging these in to our function, we get A cubed plus 1 over 2 equals B cubed plus 1 over 2. So if we multiply by 2, we get A cubed plus 1 equals B cubed plus 1. And then subtracting 1, we get A cubed equals B cubed. And then here I'm talking about real numbers, so I can take the cube root, taking the cube root of both sides, we get A equals B, and f is 1 to 1. So we've proven that this function is 1 to 1. So now we need to prove that it's onto. So we're going to start with our outline for onto. We're going to pick an R in the real numbers, and we need to show that there exists an x in R such that f of x equals R. So we need to find this value of x. So if I look at I want x cubed plus 1 over 2 to be equal to R. That means I want x cubed plus 1 equals 2R. X cubed equals 2R minus 1. You can take the cube root of any number, cube root, and that's our value for x. So now let's write the proof here for onto. Let R be an R. We must show that there exists an x in R such that f of x equals R. Consider x equal to the cube root of 2R minus 1, which is in R. Then I'm going to plug that in place of x into my function, the cube root, 2R minus 1. So we get the cube root of 2R minus 1 cubed plus 1 over 2. That'll be 2R minus 1 plus 1 over 2, which will be equal to R. Therefore, our function f is onto, since f is 1 to 1, and onto f is bijective. So we've completed part A of the problem. So now we just need to do part B, which is where we find the inverse So f composed f inverse, remember this is the identity function, so when I input in x, it outputs x. F of f inverse of x. So then f inverse of x cubed plus 1 over 2 equals x. You're just plugging in f inverse into the f function and then solving for f inverse of x cubed plus 1 equals 2x. F inverse of x cubed equals 2x minus 1. So f inverse of x would be the cube root of 2x minus 1. And there is my inverse function for f.